Hey everyone, I am Miss Hu, your physics teacher. In this video, we're going to go through the safety precautions in terms of radioactivity when it comes to handling, storing, and moving radioactive materials. This is a topic in both the SPM and IGCSE physics syllabus. There's of course a lot more to know when it comes to handling radioactive materials, so please feel free to do your own research or you can watch my other educational videos. What I'll be covering in this video is just the general information that you would need to be able to answer the questions in your examinations. So let's get right to it. So what we'll be covering in this video lesson would include the effects of ionizing radiation on living cells, how radioactive materials are moved, used, and stored in a safe way, as well as general safety precautions. So first of all, let's look at the effects of ionizing radiation on living cells. So these living cells could be human cells, plant cells, animal cells, whichever the case is, they're living. So the ionizing radiation here refers to, of course, radioactive radiation. For example, alpha, beta, gamma, even X-rays. Now, if exposed to very, very high levels where the energy is way too high, it could lead to immediate cell death or injuries leading to cell death. This can also cause radiation burns. If exposed to lower levels but very long-term exposure, the ionizing radiation could also cause harm because the ionization process of the radiation can cause the DNA of the cells to change. So this can lead to mutation, which can also lead to cancer. Now, of course, these effects are terrible. And obviously, we want to try to reduce the use of ionizing radiation whenever possible. However, ionizing radiation is extremely useful, as you would have watched in my uses of ionizing radiation. So sometimes we do have to handle ionizing radiation. So let's be smart. Let's not be stupid. We have to go through safety precautions to try to minimize any danger in terms of ionizing radiation on living cells. So when handling and storing radioactive material, let me put my face here. Obviously, we need to use a box that's able to safely contain the radioactive material. Now let's recall the shields of alpha, beta, and gamma. Alpha can be stopped by paper, beta can be stopped by aluminium, while gamma can be reduced with lead boxes. So usually we'd have to use a box that's able to contain the most penetrative ionizing radiation. In this case, the most penetrative one is gamma. So to contain gamma, we use lead. Now, even though alpha and beta can be stopped with thinner material, we would still use lead boxes because having a box that can store all radioactive radiation would be much easier than to say, okay, this is reserved for alpha, this is for beta, this is for gamma. Too much of a hassle. Let's just use a box made out of material that can contain all radioactive material. That's why we always use lead boxes. And obviously, you need to label it so that people don't simply open and carry things with their bare hands, right? So that's why you must have the radioactive label. Now, if we were to transport radioactive materials, let's say by land or by sea, by road, the authorities must be informed and permit must be applied. Now, only approved transporters and routes to be used. That means only those that have been trained to be able to handle radioactive material are allowed to handle and transport the radioactive material. The correct boxes must be used. The correct vehicles that are lead lined must be used, and the routes must be pre-approved because you can't be carrying radioactive material in general public. So sometimes you have to clear the road, block that road so that no one else is using that road during the transportation of the radioactive material. You cannot carry radioactive material with normal cargo among the general public, with normal people within that transport as well. If you have to handle the radioactive material, for example, in the lab, you must never touch the highly radioactive material with your bare skin. Always handle it with tongs or with gloves. So the reason for this is because you don't want the radioactive material to stay on your skin. You never know, right? For example, if there's radioactive particles that get stuck in your skin or you breathe it in, or if it's radioactive liquid that gets, spilled onto your skin, And when that happens, it's very difficult to remove. So you have to wear protective material so that it's easy to just remove in case of any contamination. So then better to wear a lead apron that's able to absorb the radiation and wear personal protective equipment to avoid any direct contact, especially when it comes to liquids or gases. And as always, apply common sense. So it goes without saying, you must not have food and drink near you if you're handling radioactive material. So because that's common sense, that kind of answer is not accepted in your exam questions. So a safety precaution does not include food and drink, no, but no. When it comes to safety precautions, talk about the lead boxes, talk about the tongs and gloves and a lead apron. Okay, so these are safety precautions that if you didn't know about radioactive material, you wouldn't realize it. But now you know, apply it when handling radioactive material. So once you know about nuclear emissions in terms of their nature and how they ionize and how they behave, the safety precautions that we want to apply is also very logical. So for one, you want to minimize exposure time, which means how much time you spend with the radioactive material. So you only handle the radioactive material when you need to. Don't sit in a lab like, okay, I want to do my work here, and you have the radioactive material right next to you, and no, if you don't need to use it and if you don't need to be near it, then put the radioactive material far away and go and work in a place that does not have the radioactive material. So minimize any time you would spend with the radioactive material. Keep it as short as possible. You'd also want to maximize the distance between the radioactive material and living tissue. The further away, the better. So for example, use tongs because that maximizes the distance between you and that radioactive material. Or another way is if the material is very radioactive, you put it into another room and you handle it using a robot instead of you handling the material yourself. Also, use shields whenever possible to absorb the ionizing radiation. So, for example, if you're handling gamma, you want to put lead shields in between to reduce the gamma exposure that you might receive. And that's it. So, if you found this video educational and helpful, please click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Miss Ho. Happy studying!